All right, you hear it. Good. So first, Python, what is Python? I mean, you guys have probably some experience with shell scripts, and this is quite similar to that. So Python is an interpreted language. It means it goes from step to step. It doesn't do a compilation into an executable or anything like that. It stays as a script and then it's run as such. That makes it, similar to a script, very easy to debug. You can basically just look step by step what is happening. You can run it as a whole script, but you can also run it step by step. The way you can go to a shell and you can type cd or ls, the same thing you can do with Python. You can basically do one command at a time in the Python interpreter. So that makes it much more approachable from a beginner's level. And also, as I said, it's much easier to debug things. And so that's the interpreted and interactive piece. And it's very much thought as a beginner's language, so it doesn't necessarily offer all the high-level things that maybe some more advanced languages offers. But unlike Shell, it is a truly full programming language. It's object-oriented. You can create objects. You can have all kinds of complex things if you want to do it, but also you can stay at a very basic level and you never touch all that stuff that you could do. Of course, today we're going to stay at beginner's level. We're not going to go talk about objects or even functions. We're not even going to go there, but we're going to basically treat this from a purpose here as a scripting, as a simple scripting language. Now, why do Python or when do shell scripting? Well, anything that's more of a complex task, anything that needs calculations or that needs handling of tables, etc., that's much better done in Python. If you want to do more than just scripting, but also want to do some data analysis, yes, definitely go to Python. There, the question not becomes between Python or Shell, but between Python or R. And Python, the nice thing is it really kind of can do everything. So it can do the data analysis, it can do the file handling, you can do this just general scripting. It is really a jack of all trades language. That's really nice. So for those of you who are currently not using Python, this is something very good to learn. And you'll, however deep you want to delve in this, it's going to be useful to you. One of the things that I mentioned here, the caution, though many of you have been used a little bit to shell scripts, whether those are bash scripts or TC or C shell scripts. The one big difference between Python is that Python cares about indents, basically white spaces. So whereas in the shell script, you could organize your stuff however you like. In Python, that actually straightforward matters. So those white spaces or the indentation at the beginning of the line, that's what groups the code. If you think about in a if statement in a shell script, you have an if and then and an end if. That end if is not there in a Python script, because where the end is of your block of code that goes into an if is managed through the indentation, or how far your code goes in. And unfortunately, whether that indentation is done with a tab or a space is different, means something different in Python. And when you just look at your general editor, you won't see a difference. So if your Python stuff is not working in Python script, that's usually one of the first things to check. Now, also one thing more here, multi-line statements, in order to make things nice and easy, multi-line statements need to be done with this backslash thing. So as soon as you do backslash, the next line is going to be interpreted as if you would be continuing writing. And so that's pretty nice. So you're going to be using that a lot in your code. Let's see here, the next here. we're going to talk about editors next, but one thing I mentioned before is about this indentation. It's very important that you have an editor that understands Python, so that they show you whether you use tabs or spaces at the beginning of your line, because that matters to the execution of Python. You know, when you run Python, there's different ways you can do this. Well, you could write a script and run it. Well, that's the second option here. Running a Python script is just Python 3, if you use Python 3, which is, I suggest you do. And then write your Python script, it's going to run it, as if you've had a shell script. Now, you can even add the first line, just like we do in shell script. We add the first line like a pound exclamation point and the path to the TC shell or your bash. You can do that too with Python. Then you can run it like an executable. So you don't have to add Python 3. You can just type myscript.py and let it go. Of course, you have to first make it the permissions that you can execute. Another way to run it is just to basically, I didn't even mention that here, to just run Python 3, and then you get a shell, just a Python shell. And you can just type in there one command after the other. That's, of course, not a script, and we would use it as a shell. What we're going to be learning today is how to do that with Jupyter. So Jupyter is kind of like the shell, except for you have a graphical representation. And if there's an easy way to go back and forth. Those of you who know about MATLAB, it's kind of a little bit like the MATLAB interface, the graphical user interface for MATLAB, or even more appropriately, the graphical user interface of Mathematica. So I assume most of you don't remember or have ever played around with Mathematica. So we'll get exactly, that's what we were working on today. How we're going to be using Jupyter to create a script, and then maybe then later use that script. All right. Next one. So Python setup. So we have the easiest way to use Python. First of all, most of your computers will have Python already installed, but some of them will only have older versions of Python pre-installed, which is Python 2. We definitely suggest you do your own additional installation. If you want to do it on your computer, for example, on your Mac or on your Windows machine, I suggest you download an Anaconda package. Anaconda is a tool you can go online. It's freely available. Just make sure you use the Python 3 version for Anaconda. Download it, and it has everything already nicely set up. That, of course, means you need to have the data locally. What we're going to be doing today is really how we're going to be doing this if the data is on the system at the Neuro, without needing to download the data. Because you can do this very efficiently, even with slow internet and everything like that, without needing to download the data, do it on your local machine, and then upload the data again. But you can do it directly on the system over there. So we're going to be working on Janus today, but any of the servers would work as well. Now, since that means if we're doing this, the Python will actually run on Janus. It will not take a lot of cycles, so don't worry about that. But the problem is, this is just for general, simple Python stuff, not for deep learning. I wouldn't use this for deep learning, particularly also because this is our logging server. You shouldn't be running anything heavy on the logging server. Now, in order to do that the easiest way, so that you can just type Python 3 or anything like that, you see here, you have to add a certain binary thing to your path. Now, you can add that to your traditional .out CSHRC, which is setting up your paths and everything like that for your TC shell. So you can just add that to things. By the way, you don't have to write this down. I'm going to upload this on the alongside with the video on the website as usual. Now, if in order to do it today, rather than you adding that to the our CXHRC, you can just run this by yourself before you do, like you can log in, do this setting, and then you should be done. All right. So very soon the hands-on part is going to come. This is only first introduction. Clearly, running this twice. Yeah, and so yeah. So I mentioned this before. Editing Python script. You can use your favorite editor. I suggest you use Sublime, which we have on our system. It's SUBL if you want to run it. It has a really nice specific Python mode. So for example, I use for everything other than Python, I use Emacs, but when I go to Python, I use Sublime. If I do script. Now, alternatively, you're going to be using Jupyter. That's what I'm going to show today, because that's much more straightforward. All right, starting Jupyter Notebook. So this is going to be the first hand-on thing. So let's see whether we can get this to start. Well, if you are at the lab, you log in and you're on your machine, and assuming things have been set up correctly, you should just be able to type Jupyter Notebook. So if you have that line that I showed before, the set end line, let me actually copy that here as well, so we can set it here. Copy that to that. Here. Just gonna add that here. Why did it not copy? It didn't work. Okay, let me do this again.
Stay there for a minute, Martin.
Yeah.
I need to get that.
Well, so I'm going to copy it to that slide that we're going to be saying.
Oh, I see. Okay.
That's what I'm trying to do.
Gotcha.
I'll try to copy this here. Yes. All right. So what I want you to do, make sure you have your VPN first running. Then you SSH into Janus. So like you see, you log into Janus using SSH, your onion, Janus, IIUNCED. No need for -X or anything like that. Just traditional SSH, as if you would be operating on the shell. Once you log in and get your prompt, you can see whether I have done that here. Yep, I'm still here. So that's my home directory. You need to do this setting. Now, I'm not doing that because I've already done it. It's already in my path. So if I take where Jupyter, it will tell me, yes, that's where it is. Python 3.8 in Jupyter. Then assuming that you've done that, and we'll wait until everybody is
Hey, Martin.
There. Yeah.
Can you take your home screen off the path, the environmental path I'm supposed to be looking at?
Can you see the path again?
No.
What do you mean?
Like your slide is currently covered by your terminal.
This?
In my view.
Well, that may be a screen sharing issue. Should not be. Now I'm showing my fully my.
Oh, there we go. Thank you.
It's just an up. Yeah, I mean that's probably an update because of the speed, I guess, of the internet. So yeah, so do this set end path thing. This is for TC shell. If you use Bash, you would have to do it slightly differently. But if you use Bash, you probably know how to do this. And so what we're going to be doing then next is, in order to make things fast, usually you before you start Jupyter, the easiest is you go to your folder where you have your Python scripts, or wherever your Python script that you right now creating. And so we're going to go to the folder where the Python script is that I created today, for today. And you see that we should go into that folder. That's Neuro Tools, Python, Examples, Merging CSV. I'll do that exactly here. Maybe make that a bit larger so you guys can see that. All right, CV type, Neuro Tools, Python, Examples. Sweet. We have a few things here. Really what you need is the location here. We will create that tool. Now I have already created it. You can load that one, or you can create your own. But for the purpose here, maybe just use what we have here. I have here some CSV files. That is one CSV file here. This is this brain tissue volume CSV file. That's a CSV that contains reporting about brain tissue volumes. And this is reporting about, for example, CT, cortical thickness data. And I want to combine this stuff together into one single one. We have another one here also that's called subcortical. Where's the subcortical? Here. That's the subcortical. But these are three files we want to merge into a single file to give to somebody else. We'll show you how to merge them, how to select things out, maybe only report certain stuff. But before we go there, well, we have to start up Jupyter. So to start up Jupyter, what we need to do, I'm going back here quickly to the presentation, is we have to start up Jupyter with a given port. So we're not wanting to visualize Jupyter over at Janus, but we're saying, well, start up Jupyter, but use this port, and then anybody who connects to that port can use that. Now, since we're all doing all this on Janus, each of you should use a different port. I don't think it works if we all would use the same port. So I have here 88888, but you can use anything. 1, 2, 3, 4, doesn't really matter. You can even make it 5, 6 to make it easily unique. All right, so I'm going to just do that here as well. So I'm going to use a new one. I'm going to say 7127, just random number. And you see what I did here first, it says notebook. Now, Jupyter has different things it can start up. Notebook is the easiest way for you to create a script. So it will start up Jupyter, and it will create the notebook interface. And I tell it, this is usually run through a browser. I tell it not to run locally a browser, but put this on port 7127. If you don't want to remember this, you can easily create an alias, and then that's going to be doing it. So I'm going to run this now. I'm just going to wait this a little bit, and you can see here, it comes, says serving notebook from local directory. And then it says the Jupyter notebook is running at blah, 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 blah. To access the notebook, open this file in a browser. Now that one would be a local one, the first one. If I would run it on a browser on Janus, that's of course not what I want to do. I want to run a browser on my machine, my local laptop. And that would be here. This is the way this would be done. Now, in order to run this on your local browser, we need to start up another SSH that connects your machine to that port we just opened. That's so-called SSH tunneling. So we need to actually have two SSH running. One SSH now runs this Jupyter notebook, and the other one creates the tunnel so that we can run the Jupyter Notebook on our local machine. So to do that, you see that here, we need to create an SSH tunnel. And that's probably something that you have not done before. It is something, again, you can put that into an alias so that you don't even have to remember it, but it's rather straightforward. It's basically this SSH minus NL, and then you say the local port goes to localhost on the other port for the machine you're connecting with. And, this is actually, this should be all in one line. I'm just going to make this in a new line so you can see that.
Hey, Martin, this is Rachel.
Yeah.
I'm sorry, but I'm lost currently.
So
So
yes.
when you say create an SSH tunnel and do I need to open my shell script tool, like program again, or do I do this in the same?
How did you create the first SSH?
Using the PuTTY program.
Okay, so you're on Windows, that means.
Yes.
Okay, so now you on PuTTY, you have to do that as well. Yes. So how did you open? So I'm not the most knowledgeable about PuTTY.
And I have other options, like I have secure shell or CRT I can use.
So you can do this in PuTTY.
Okay.
Yes.
So all I did is double click my desktop icon, and like the prompt that comes up is SSH to begin with.
Mm-hmm.
So I don't know how to give it flags.
So
Like I usually just put my onion in.
So when you start up PuTTY, double click on an executable.
Yeah.
The PuTTY executable.
Yeah.
I'm sure there is a way to do it in PuTTY.
I'm happy to use something else. I just don't know I don't know how to do it.
No, because I looked this up. There is, in PuTTY, you can create a secure shell with predefined things.
Okay.
So that's why I was saying is with PuTTY, is there kind of like a preference menu or selection or something like that?
Yeah, I mean, if I right click on it and go to my properties, that's not really what I need though.
No.
Okay, hang on a second. Let me just give me a minute. Yeah. I have a configuration window.
And so there should be a configuration and it should allow you to exactly specify that, like the SSH tunneling.
I mean, hang on, let me look.
Let me quickly see. Okay.
And there's a lot of different options.
Do we have any oranges?
No, we can't.
All right, so see.
Sorry, everybody.
No, that's okay. So you have PuTTY.
Oh, all right.
So,
Okay. Yep. So there's an SSH option under my connections that has various options, including tunnels.
Do you see my screen?
Oh yeah, I can see it.
So there,
Yep.
you on the forwarding ports, you can add a new port.
Okay.
And so that has to be the same port number as you did specify when you started the Jupyter.
Okay. So just put my port number in there.
So it should look like the screenshot that I have from the Stack Overflow.
Okay.
I mean, yes.
All right. I can't type in that big top window that says forwarded ports. I can't like click in it and type it.
I think you click add new forwarded port below it. You add it there, source port and destination port, and then you click add. So you see below the window.
Yeah.
So you. So you can, as for example, I used 888. You can use twice 88888 in the source and the destination port. The source port is at the place where you're connecting, and the destination port is your local port, or vice versa. I don't know exactly with PuTTY. but I'm using usually the same port number in both ends, so that makes it easy.
Okay, so I just put the 4-digit number in both source and destination.
And then make sure it's on local, exactly.
Yeah.
Tag.
It tells me I need to specify a destination address.
Yes, both in the source port and in the destination, you need to put that 4-digit number in.
Yeah, I did. Do I need other text or just the number? It's okay, hold on. In destination address in the form host.name:port.
Sorry, what? Yeah, I mean, I cannot.
Okay. Yeah, never mind. Okay. Hold on a second.
So, those of you who are on the Mac,
Okay.
you can start up terminal. And once you have the terminal, you can just basically run this line here.
Okay, so I got this part.
Right, so,
And then just select it and click open.
yes, so you have to actually start that. That's the thing, exactly. Let's see here. I want this one here. Control C. And I, of course, keep up. That's probably not really what did I name mine? It was called 7127. All right, so I do that here. Again, do this instead of 888, 7127, whichever thing you use.
Pretty slick.
And of course, type in your password. And if it all worked, well, clearly did not work. Then actually, man, yeah, that's not going.
You have typed onion at janis@.io. I think you need your own onion.
Oh, yes. Thank you. Yeah, that should.
Oh, yeah, I didn't notice that part.
Yeah, you cannot say onion. Yes. Thank you. That was very helpful, Hina. I've been typing along here for a long time. And so if that worked, then you can see it's nothing comes back, basically empty, because now it's listening on that port. And so that now means that SSH created the linkage from the port at Janos, so at the lab, to your local machine. And now you can take that localhost link that was given to you when you started up Jupyter, and you can copy paste that into your local browser. And when you do that, something like this should come up.
Yep. Pretty slick.
So let's wait for Rachel, maybe also Ashley, to be this far along. Rachel, tell me when you're at this stage. And if there's a problem, let me know. We'll try to coach you through it.
Okay, I'm sorry. I was figuring out my own problem, so I missed a few steps. I'm sorry. So I'm logged in. I think I have my second shell. So now what do I do?
So the second shell just created that link. And so there's not much more you can do with that.
Okay.
Now basically let that shell open. Don't close it.
Okay. So just minimize it. Okay.
Go to the shell where you started your Jupyter.
Yep.
You copy that link.
Copy. Which one?
The
Oh, that top. I see. Okay.
localhost.
Okay.
The 127.001 should also work. Should be the same on most machines.
Okay. And then go to my local browser.
Go in your local browser and just paste that into the. Okay. And then it should work.
It's saying this site can't be reached.
Did you so it says this site cannot be reached, and it's
Local host refused to connect.
Okay, That's okay. That's why we're doing this hands-on.
Astronaut in space.
Does it matter what browser I use?
Shouldn't be. I've used this on Firefox. I've used it in Safari.
Chrome?
It work on Internet Explorer. Yeah, I've used it on Chrome too. It definitely works on Chrome.
All right.
So, yeah, so double check whether there's maybe any spaces before the HTTPS. So what does your, you copied the full link,
Yeah.
everything included. And the link looks correctly at the top of your screen. It says
Hang on a second.
localhost colon and then your port that you opened.
Yep.
And so that port number that you have is
Yep.
correct. Now double check your the putty that the shell that you opened that for the tunneling. Whether
Mhm.
that correctly specified the port number.
So no, that doesn't look any different than my other one.
What do you mean? Yeah, no, it shouldn't look any different. No, in the configuration of it. I'm just trying to make sure that you indeed are tunneling the right port.
Oops. How do I check that once I'm in it?
It's a good question. Can you see the configuration still?
No.
No.
Why?
It's a good question. How do you check?
I think if you, let me just test this real quick.
Are you using putty too, Joe?
No, I'm on a CentOS 7.
Okay. That's easy.
Monkey dog.
I mean, so Mac and Linux, of course, are easiest because the underneath is a Unix system. You can see it nicely, but so that's the only thing right now that I think is going wrong on your end, Rachel, is that it's not the right port that's
Okay.
being forwarded. So if you maybe start up or look at the next putty configuration, let's see whether we can start up a new putty, just to double check how its configuration would look like.
Okay.
And go back to how.
So Rachel, I see you attached to port 8782.
Uh-huh.
So that's what you're using.
Okay. Yeah, that's what
Well, that's probably the port that she opened. Do you see that? But do you see whether that's the shell that?
Oh no, I can't see that information.
Ah, that's true. You're just looking at which services are running.
Yep.
Like which and you see that she actually connected to the right port.
I see. I don't know if it's correct, but she's on 8782. As long as they're both, so as that's what's specified in that cut and paste line, I guess she should be okay.
I mean, does it have to do with like local firewall stuff?
No,
Or local browser restrictions?
Local host.
no, shouldn't.
No.
It could be something in your browser, but I doubt it.
Yeah.
I don't know. You'd be surprised. Chris is pretty aggressive about the privacy settings.
That's okay. So how do you see that, Joe?
If you do PS minus EF and just grep rather for Gimple, the username.
Yeah. Yes, sure. But yeah, I see. So but I see the notebook running 8782, but
Right.
I don't see where her SSH connects to.
Mm.
Well, let me
So-
try.
So
Okay.
we know that that's more the question, like, is her SSH running the 8792 tunnel?
Yeah.
That was the thing I was.
Yeah, hang on. That's not so easy to find.
Do you want me to use a different connection tool?
No, so what I would do is start, close the current tunneling
Yeah.
putty
Yep.
and start up a new tunneling putty.
Yeah, I'm just not sure I'm doing that right. So that's why I was thinking I should do something else.
Well, are you sure you correctly specified the tunneling on that pudding?
That's what I don't know. They're in different windows. And so like where I connect to Janice and where I specify the tunneling are like different configuration windows. So I don't know if one disappears when I switch to the other. Like, I know that sounds
Okay.
weird, but
Um,
Solid.
so, I mean, I don't want to hold everybody else up. So I can like forget the hands-on part and just follow along with everybody else. So we don't hold everybody up.
okay. Okay. Then you can do the hands-on maybe by yourself.
Yeah.
No, the hands-on is nice because there's not a lot we're gonna be doing, but it would have been really nice for you to be doing this by yourself.
Well, I agree, but I don't want to, we
We
don't need to troubleshoot my technical difficulties for everybody. So
Yeah.
that gets tedious.
I mean, well, so I have a small technical difficulty too. So, and nothing. It's small potatoes. It's just how did you find the Jupyter notebook? What do I have to set?
This one here.
Going path. Okay.
As long as you set the path correct, then Jupyter Notebook will go the right way. Now, you can of course also type tools, Python 3.8.
Right.
You can type out the whole thing. That works too.
Rachel, what port do you think you're connected to?
I'm sorry, what?
What port do you think you're connected to for your
The 8782.
Okay.
But I closed that one out and then I'm trying again.
Gotcha.
Yeah.
All right. I'll shut up now.
So,
I mean, do I need to check any of my port forwarding boxes? Like local ports accept connections from other hosts, like any of that stuff?
Maybe use, well, if you have a local port forwarding and you're exactly using that port,
yeah,
that would be very surprising, but that could be happening, yes.
So yes, try that, or?
No, don't do it port forwarding. No, it's more the other way around. If there is already a port forwarding happening on the port that you randomly selected, then you have a problem. There's already existing port forwarding, but that's very unlikely.
How the fuck is it not?
All right, so well, maybe then for the time being, let's continue on and maybe come back later, maybe if Rachel hasn't been able to solve it later on. But Rachel, then maybe right now it's better for you to, rather than solving it,
watch what's going on. Yeah.
So the screen that comes up, you can see the screen on what I'm recording here. That comes up. You have here the file that is a notebook. You can see that it has this special icon here, and it has an ending of IPYNB. What it exactly means, I don't know. Probably interactive Python notebook. I don't know. That kind of looks like that. So that also means this is not something what we're right now creating that you can directly give to Python, but you can export that to a Python script. Or if you want to leave it in this format, you just use it together with Jupyter. And so I'm going to click on that, and then Jupyter will open it. And I just right-click on it. That's how Jupyter looks like. And this is a typical notebook. And notebook consists of cells. You can see, and then I'm clicking on what about each cell is. And each of these cells can be run separately. So usually you would run them top to bottom, but you can always go back and run something again if you want to. And you can see here, I've already started to do this to make things easier, but you can also start your own notebook very easily. On the top, you have some interface of how to work with things. The one thing that you need to know is if you want to run a certain cell, you can go here and click on cell and say run cells. You can also click this run button. That runs that cell. Or you can click in the thing and do shift return. If you do shift return, it runs it too. Now, the first time you run a cell, that's when it starts up the Python program. And that's when it takes a little bit longer, just a tiny bit longer. So all the other shells will be much quicker for that. And the first shells that or the first commands you usually do is you do import commands. Import says, hey, give me this library because I want to do something with it. And here I'm importing pandas. Pandas is a Python library that's specific for working with data, and merging data and doing things with them, organizing them. These things, the data we load are called data frames, and then you can work with those data frames. But a data frame is a special data structure of pandas, of that library. So that's one thing that makes Python so strong, that there are so many publicly available libraries that give so much functionality. So yeah, so also one thing you can see here, what is very nice, is when you load a notebook, you see the output of your last run, whenever you last left it. And so you can immediately see what worked, what did not work. It's also easy to take screenshots of the outputs, etc. So that's something that's very nice and intuitive. So yeah, so going back quickly here, if you do an import in Python, you can either import the whole package, for example, import pandas, and then whenever you're going to be using a function in that package, like pandas, you would write pandas dot and then the function in that package. Or you could say import package as and give it a nickname. Let's say if the package name is super long and you don't want to always write that long, you can say import package as. And that's what I've done in this thing, where you can import pandas as PD. So whenever I want to use something in pandas, I can just say PD dot. I could also write pandas in the dot, but easiest is to write PD stuff. So it makes it easy to things. Then I can also make it such that certain functions, I do not need to have first that PD or pandas, but I can directly name that function. And that's when we're using, instead of import, we would say from, and then you would say the package, you import a certain function. So for example, from the collections package, I import the function counter. By the way, if you're looking for things, certain functions, etc., what you're doing, just Google. So Google package Python and the function you're looking for, and usually there's something there. When you're organizing data, with pandas is usually nearly everything you need. So pandas is going to be your best friends to work with data. So the next thing is using the pandas function for, well, actually, here, see, yeah, documentation for pandas is on pandas.pydata.org. It has all the documentation there if you need it. I'm going to talk about, obviously, most of it today that we need for the tutorial. But if you need to know more, that's where you can go. There is a function to read CSV. It's called read CSV, unsurprisingly. And when you load it, it assumes you have a header row. So this doesn't work for CSV data that doesn't have a header row, because Pandas wants to know what each row is called. It's called the key of a row. And also, it assumes that you can give it an index column. So the index column is something that would be unique for each row. And each row is a data set. So that's the way Pandas works with CSV data, that each row is a data set, and there's going to be at least one column that uniquely identifies the data. That makes it easier, and that's called the index. So if you do that, you have this read CSV, and you have then a dot set index. And what you write in there is the actual name of the header of that column. One thing that you can see here too, the way we do strings in Python uses the quote symbol. So we would here do pd.read_CSV, have your CSV file, however it's called, and then .set_index candidate ID. Now, by the way, that name, that can be a whole path if you want to do that. Now, it's easiest, of course, if it's locally to your notebook or to your Python data, and then you can just write the name. You can see that here. Also, so we have now this outside, the Jupyter Notebook will keep tab of in which order things run. So you can see here, that is the second cell that was run. If I would run it again, I'm just going to run it again. You see there, it's the third that was run. You can see now there's 2 in 3s because it's, the one below is from the last run. If you want to, in Jupyter, just look at the data, you can just type it. So like here, for example, this soup data, that variable soup data that read the O soup cortical volume LVHT.csv, and I can look at that. Now, in order to get to this stage, the only thing that I did is I loaded the CSV data that was created by our script. And sometimes I may need to change something about the candidate ID. Sometimes there may be a file name. So I need to first remove the .nerd or something like that. But yeah, so you have here, what it shows at the beginning is that key index, which is the unique thing per row. And then it just shows me whatever else is there. You can see I can scroll here. Now it doesn't show all the data. It has these dots. So it only shows you part of the data. Here, this is small enough that it shows all columns. So it shows you all the columns that are in here. And also, it doesn't show all the rows. There's some dots there. One thing you can see here too, always good to check. Well, there's a 1,521 rows, so that's how many subjects you should have in this data set. One thing that I did here preemptively, I also went and changed the visit to visit subcorticals. The reason why I did that is because once we start merging things together, and we may have different CSV files that have the same column, the programs will not know what to do exactly with these same columns, whether to merge them or not merge them, usually just basically adds them together. So the best thing is to make sure that the column names, the headers, are unique across your CSVs, except for that key that you want to use for merging.
Hey, Martin, this is Rachel. When you say that you changed that column name, you're saying you changed it in the CSV before you read it into this?
Correct. I went to Excel, wrote it into Excel, and I changed the visit to visit subcorticals.
Okay. And for that column, because I know this is IBIS data, so this is nice for me because it's familiar. That candidate ID at the beginning, so it's not unique per row because there are different visits, but that's okay?
That's okay. It doesn't necessitate it. You can see it clearly, there was no complaining, no warning. Now, when we are going to be merging things, and that candidate ID is the thing we're going to be using for merging, not unique, things become a bit more complex. So what I will have to do first is, since now here we have different visits with the same candidate ID, I'm going to select out the visit first. So I'm going to show you how I'm going to select out the visit and then merge it.
So if in the end we wanted to actually have all the visits together rather than select them out, we would need to adjust that index to be something that is unique. So for example, when I deal with the data, I usually do like the candidate ID _ visit label.
That would be perfect. You could use that.
Okay.
You
So,
would
okay.
have to make sure that you use that same convention in
For
all
everything.
the
Yeah.
We can merge them.
Okay. Okay. So I will follow along with the way you did it, but it's good to know that there are other options. But that would be something I'd need to do in the CSVs ahead of time before reading them in here.
Yes, you need to prep your CSVs a little bit for the merging. Now, there's probably ways.
I can ride my scooter fast.
Okay.
Sorry.
So you can, there's also ways you can do this in Python, but to be honest, that kind of interaction where you're just changing the header of something, that's easiest done in Excel or even just your editor. So,
Okay, thanks.
so now the next step is, so yeah, first look at the data, there's the key index, all right, that's good. Now, selecting data. I specifically did it like this because I wanted to have only the VO6s to merge. So how do I select now only the data where my visit subcortical is VO6? And this can actually be done fairly straightforward. You see there on the next cell, it says these subcortical data is, now I'm first selecting the indices where a certain criterion is fulfilled. And that, first of all, this bracket that we use selects part of a data frame or part of an array. And in there, I'm using the same array again to just say which ones do I want to have. That's only the ones that have visit subcortical equal to VO6. And so this selection criterion is something that you can use very, very straightforwardly, and I use that a lot. If you want to double check, you can count the number of non-zero elements that are in there, or you can use the counter functions that does a little bit more of summarizing. We're going to go over to the thing again for doing this. So here, you can see this one here, so I'm going to run this again. What you have here now is you created a new variable that has only those indices or only those rows where the visit is VO6. And I do that both for my subcortical data as well as for my cortical thickness data, because I have the same thing in the cortical thickness where I have multiple visits. And you see here, also in the cortical thickness data, I went in and I changed the visit to visit CT in the heading. And then I end the cell with visualizing what this sub data VO6 looks like. See here we have 488 rows, 13 columns, and obviously they all look like in VO6 here. I can even select only a single column out, just for me to visualize. I could say sub data VO6, and I'm gonna then take the column with a certain name, in this case left amygdala, and I'll just drop that for me out if I want to look at that. I can also do a count. Now, the count that's in pandas. So this is the count that is offered by the pandas package. You'll see basically counts how many non-empty elements do you have for each of your columns. So if one of the columns would be left empty, then this would not be 488 everywhere. So it's an easy way to check whether you have a full data or whether some places you may have NA or an empty entry. This two, and this one here. And then I can use this counter, and the counter, you can see here, I can give it a way how I want to organize it. So I can say, well, I'm going to go back to all of the subcortical data, and I tell it to use the visit subcorticals as the thing to order my counter. And then it tells me, well, I have 488 VO6, and so on and so on. So I can easily see how many rows I have according to these visit numbers. So, all right, so now we have the data. I'm gonna just here also do that on the, oh, this one here first, on the CT, where I can also see on the CT, on the VO6, I have a different number. So you can see here, I have the tissue stuff, which only has a 6-month-old, has 488. My subcortical, I selected now out only the 6-month-old, also have 488, but the cortical thickness is 376. So I already know once I'm going to merge, I'm going to lose data. And at least if I want all of the data to be present. So that's what the next thing is about. So now we're wanting to merge all of these three things. So we're going to merge the cortical thickness, the subcortical information, and the tissue information. All right, and so how do we do that? Well, merge can merge 2 data frames at a time. So we cannot do all 3 together, but we have to do it in 2 steps. First, merge 2 of them, and then merge the result of that with the third. Merging has several important parameters, and I'm going to focus here only on the most important ones. The rest really you don't need to care too much about, but you can look through the documentation to know more. So the first thing is validate. You don't have to validate the output, but I strongly suggest that basically that checks whether each of your keys is unique or not. So here validate, so I use 1-to-1. That's an option that I provide. Now what that means is that when I merge 2 things, it will exactly find one of each in the 2 data frames to merge. So that I know I'm not merging 1 line here with multiple line here or something like that, but it's exactly 1-to-1. And if that's not the case, it will give you a warning, says, hey, I found 1 key in the CT data that has 3 keys in the subcortical data. Then you probably already know, hey, something is off. Then also what you have to specify is that you have keys on both sides. That's the usual way you're going to be using merge. So that's why you have to say left index is true and right index is true. So that say, yeah, use the index in both the left of the left data frame and the right data frame. Then for the actual merge, there's 2 ways to do this. And that's so-called inner and outer. The inner means the keys need to be, basically it's an or and. The inner is like an and, meaning any key needs to be present in both data frames. Remember how I said that the cortical thickness data has a lower number of measurements than the subcortical data. So now, one way to merge them is say, hey, I only want what's in both. That's inner, or the and combination. The outer would be, oh no, I want also the ones that's only in 1. Just wherever you don't have a match, leave the values empty. That would be the outer, meaning an or. It either has to be in 1 or in the other, and whatever is not present in the other, leave empty. And so if you want to combine data and you want to keep everything present, then you want to use outer. If you want to combine the data and you only want the stuff that's everywhere, then you use inner. And so going back to my merging here, so I did this inner here, and then I did the count on the merging, and I printed it. So the count on the merging, you can see here, that one says now 376 because I did inner. That means only the stuff that's on both. Also, what you can see from this is that for every subject for who we have cortical thickness data, we have also all the other data. That's nice. But that wasn't necessarily given. So that could also have been less than 376. Cannot be more than 376 because you only have 376 for the thickness data set. And then here,
Can I ask a question? The stuff you have at the top with it, like you said, like the white spaces were important.
Yeah.
But some of your things have like spaces around the equal signs and some don't. Can you explain that?
That's a good question. So spaces are important as an indent.
Hmm.
So at the beginning of the line, that's where they're really important.
Okay.
In between, whether you have a space between the equal sign or not, that is not important. I suggest you do is just makes it more readable.
Okay.
It's not necessary. So really what I should have done is here.
And I also, I'm sorry, I missed the part about the left and right index. I was handling a child query. What are the left? I mean, I understand the left index because it's that candidate ID. What's the right index?
So the left is basically your first data frame and the right is your second data frame.
Ah.
So that just means both data frames that I want to merge have that index line.
Okay, so it's more like data set 1 and 2.
Yeah.
Okay.
Well, no, and then you have to tell it that indeed it's there. Not quite sure, like that's how I always going to use merge. But there's different ways you can use merge, even if the index line is not there.
Okay, thank you.
I also like them sorted, that's why it's sorted at the end. And the sorting is according to the index. And so this is kind of like you see here, this is the output that we get from this. We have CT, ROIs, and again, because now it's so long that it doesn't want to print everything because it's too long, you have these dot dot dots now also for the columns. To be honest, I don't know what the number is that it's going to start dot dot dotting, but it's a nice way just to look at the output. So now we have 376 by 347. That's the data we have after the merging. And this is just the next step is where we're taking and do the outer. And now, all right, don't listen to me, something is off. It should have done the outer, well, probably because of the 1-to-1. That's why it had to still have both present. No? Yes. All right. Don't look at this. You get the same output as actually before because I validated the 1-to-1. And now here, I'm doing the second merge where I'm taking the variable that I just created, the merged variable, and merge it with the tissue data. So now after this, I have all three merged together. Basically, just run it twice. By the way, you do not need to print so much as I do. Just for me, I like to see that everything I did worked. And then once it's all merged, I can save it. And saving is this, rather than read CSV to CSV. So I'm going to take this data frame I just created after the merging and just say to CSV and the file name, and it will write it. Now, if you look at that CSV, because it merged all the columns, you will have now multiple visit columns. You have one from the visit tissue, one from the subcorticals, and one from the CT. Obviously, you probably only need one because they all mean the same thing. So what I did is here is I had another selection where I took this merge value and I removed those columns that had visit tissue, visit subcortical. So this is an example that you can see where it's pretty straightforward just to let go of certain data you don't want to have. Of course, you can do this easily also in Excel if you prefer afterwards. So that's, you're selecting multiple columns. In this particular case, I have a not, in front of it, so it should not take those columns. So you see here, there's a, what I call is columns.isIn, and then it has a list. So first it selects only those columns, and then I have a tilde in front of it to invert that selection, so that it takes everything but those two columns. This way you can also very simply select only certain columns. Well, then you just, of course, you don't using the not operator. And then you save it, like I mentioned. So going one more step back. So this is basically, I'm going to select it because doing this, and then I'm going to do see another count. Now I have 2 columns less. You see before we had 352 columns. Now we only have 350 columns. And I'm going to save that. You do not need to save the notebook. It saves it automatically. It constantly updates it on the disk. So that's good. So you could just close it. If you're done, you could just close it. The notebook is preserved to whatever you've done with it. Now, if you want to take this and want to make a script out of this, what you do is you have to export it. And that's here. You say download as, and now you can see it download as a Python. So if you download this as a Python, then only the cells, not their output, but only the input cells are going to be written into a Python script, and then you can use that and you can run it as a script. Usually, since in Jupyter notebooks, you have like things where you write out the debug information, like what I have here. And usually you don't want to need that in the script. You'll have to go and then delete those lines from the script. But that's very easily done. And I think that's it for today. Yes, a little bit over time. But so, as you can see from this, is Python has a certain way to do it. You import the package you need. You have to do a certain things. In this case, loading, merging, saving, and then you're good. You also today learned how these data frames work, how you select columns and rows, not really rows, but how you select columns, individual columns, or how you leave out columns from the data. It's rather straightforward if you do this in pandas. So Rachel, do you think I know you sent me this morning some data. It's a bit late for me to incorporate it into the tutorial.
Yeah, I realized last night I hadn't done that. Sorry. I figured you wouldn't use it.
But do you think, given this tutorial, you can apply it to your data?
I think this part of the tutorial gets me through the first steps that I do. Mm-hmm. So it gets me through the merging of, for example, the lobe parcellation tissue output that's has different tissue types in different CSVs. So it would allow me to merge the gray and the white for lobe volumes from different files. Mm-hmm. What it doesn't get me is how to merge different columns that need to be combined to get a larger region. So
add them together, or
right. So for example, I need to combine different lobe regions to get the cerebrum.
Okay. So
and I need in the end
column.
What?
Basically, how to sum columns.
Yes.
How to create a column and that with a sum.
Yes. And I know, I do it in Excel, but that's where I end up having some trouble. So I know I can do it, but I have to make sure I put things in the right columns to begin with when I do that. So
we can put that on the things to present in the next tutorial. All right.
That would be great.
Any other requests? The next tutorial will be more focusing then on maybe visualizing this data as plots, histograms, so you can basically double check. So what we did right now, just by looking at the numbers, is a very simple quality control. you really want to have some visualization of the data to see whether everything looks decent or whether there's outliers there and things like that. So other than visualizing data for outliers and doing histograms, is there anything else you guys request for the next tutorial? It will be similar to this, like hands-on.
No, that sounds pretty good to me, actually.
Okay.
I mean, I think the only other big thing we need to do, but I think it fits into this, what you already did today, is to combine the measurements with the quality control information. But I think it's fundamentally the same as combining different volume files like you've done today.
It's just another CSV, it's another measurement, QC measurement, not a volumetric measurement. I mean, it has to be organized with a key that you can merge with.
Right. And one question about what you did here. So you had advised that one-to-one validation, but then it obviously messed it up when you were trying to do the outer and include everything. So would you just drop that validation if you needed to be?
Well, so rather than one-to-one, you could do one-to-many.
Okay.
Or you could just, I mean, you could just drop the validation. That's fine too. But you can say one-to-many, many-to-one, or
okay.
Or I think it's I'll have to go and look what it's called, because the one-to-many, many-to-one is not what you want.
Right, because you might have
now multiple keys.
Okay.
But what you have is where keys are in one but not in the other.
Correct.
That validation would be kind of like a none.
Yeah.
But that's an option too for a validation. Or you could, as I said, you could just probably turn off the validator. We have the outer. Let me just remove. But the nice thing about this is you can just, play around and rerun it. And that didn't do it because probably the default validation is one-to-one. That's right. Let's see here. Search that. Okay. Documentation pandas. All right. That's this one here. And you can search here for merge. And pandas data frame merge. See, uses the union of keys, the inner. Now, the special checks of merge of the specified keys. Actually, it should work in like this. All right, I'll answer that question next time. Maybe I've done something wrong on the call, but auto should do what I said it should do. That is a demo effect. All right, I'll get back to you on that one.
Okay, thanks. Because yeah, I think we'll either not end up merging together files that have different numbers, or we'll want to make sure that everybody's included.
Mm-hmm. Yeah.
And if it, do you know, since we weren't able to demonstrate it, I don't know if you know this, but when you do merge things and use the outer, does it just leave a blank?
Yes.
Okay.
Okay. All right.
All right. Thank you, Martin.
All right, that's it for today. We're 18 minutes over. Sorry about that.
Okay, that was really great. Thanks.
Yeah.
Yeah, thanks, Martin. I didn't know how to get to Jupyter remotely, so on the system, so that's nice.
So the other possibility is, rather than do the Jupyter remotely, you can download the data to your local disk.
Oh yeah, I have Anaconda and stuff too, but it's nice to know different options. And yeah, I'm definitely going to start using.
A Rachel can do.
Yeah, that might actually work better for me. I mean, the files are pretty small, so they're not. I mean, they're not hard to download. So if I continue to have trouble with that, I might just try to follow that route.
Yeah, I mean, and Python's just so nice for working with CSVs. I can definitely switching over.
And when we're back in the lab, we should be able to do this Like, do you need to run Jupyter on a certain machine, or can you?
No, no.
You-
So you saw the Jupyter is in that is in the tools bin and so on.
Yeah.
So that's in the general lab. So everybody
Okay.
can use. What you do need is a local browser because
A
that
local.
visualization is on the browser. So
Okay.
you need to have either Firefox or Chrome on your on your Unix desktop machine installed.
Okay. But most of our like our machines that are all part of the lab system should be able to do it.
Yeah, they should have Firefox.
Yeah.
So, Joe
He-
is frozen.
Yeah.
Our desktop, our Linux desktop in the lab, do they have all Firefox or Chrome installed?
Yeah, they all have Firefox. If you're CentOS 7, then they will have Chrome also. If you're CentOS 6, then no.
Okay, so yeah,
You're stuck with Firefox for the moment. But also your workstation will have to be upgraded pretty soon.
anyway, so yeah. So on CentOS 7, I definitely can recommend Chrome. That's what I always use on my local machine. So then no need to specify any ports. Just type Jupyter Notebook, and boom, it will start, like it will open up Chrome for you and start it into Chrome.
Cool. That's great. Yeah, no, I wish I switched to Python. I mean, I'm still slowly switching to Python, but I wish I did everything Python to begin with because it's so much easier to work with
And
sometimes.
it's understandable that if you're running older stuff, still in your script, there's no reason to convert your old scripts. Use them. But if you create a new one, and particularly if it is about handling data, then Python.
Yeah, I mean, it just has so many nicer functions for merging. I mean, I have a couple merging scripts and stuff in MATLAB, and they're just, I mean, I had to.
Now, things that run over lots of files, where I
Yeah.
have to easily hack file names and so on, I still do shell scripts. So.
Oh, really? Yeah. I mean, it depends. I guess there's potato everywhere, right? So.
Use what comes most natural to you.
So, but it seems like this has the merge function here seems really nice. So.
All right.
So.
Gotta run, guys.
Yeah. Thanks so much.
Thank you.
Everybody.
At 3:30 then.
Yeah. 3:30.
4:30 for, if you're not coming to the methods meeting, which is perfect.
Yeah.
4:30 is
Party.
wine. Glass of wine.
All right.
Okay, great. Take care, everybody.
Bye.
Bye. Thank you.